In this video, I have further explanation on electrophilic addition of hydrogen halides with alkene. Now, if an alkene is symmetrical, only one product can be formed. Later, we'll look at asymmetrical alkene, then we'll get more products. So what does it mean by symmetrical alkenes? Ethene is a symmetrical alkene. So if you just draw one dotted line to go through the double bond, so left hand side and right hand side, they are the same. So this kind of alkenes are symmetrical alkenes. Another example, so but2-ene, also another symmetrical alkene. Now this type of alkenes, if they undergo electrophilic addition with hydrogen halides, we get only one type of product. So let's look at alkene. The reaction of alkene with HBr. So in the first one, I want to add this hydrogen atom to the left-hand side carbon and bromine to the right-hand side carbon. So the product that I get is a bromoethane. Now, if I want to add the hydrogen atom to the right-hand side carbon, this one to the right-hand side carbon, then bromine to the carbon on the left, I also get bromoethane. So no matter which atoms I add to which carbon, the two products are the same. So technically, there's only one product. So if you do the same to this but2-ene, so add hydrogen to the carbon on the left, Cl to the carbon on the right, the product that I get is called 2-chlorobutane. So let's add hydrogen to the carbon on the right hand side and chlorine to the carbon on the left. The product that I get is also 2-chlorobutane. So when alkene molecules are symmetrical, when they react with hydrogen halides, we get only one product because they are the same, no matter which atoms we add to which carbon in the double bond. But if the alkene is asymmetrical, then the situation becomes a bit more complicated. We will get two different products. So let's draw a asymmetrical alkene. Left hand side I have 2 hydrogen, right hand side I'll add 1 CH3 group. So now if this molecule is reacting with HCl, the first one, I want to add hydrogen to the left hand side carbon. And chlorine to the right hand side carbon. So let's name this product. It is called 2-chloropropane. Now, let's do another one. This time, we'll do it differently. I will put this hydrogen to the carbon on the right hand side. and this chlorine to the carbon on the left. Let's name this product. Now this product is called 1-chloropropane. So the names are different. We get two different products. They are not the same anymore. Okay, we get two different products. So if alkene is asymmetrical, the question might ask you to write all possible organic products. So you need to write both of these. Now, other than that, you might also be asked to identify which is the major product. So one of them will be produced in a higher percentage, the other one will be lower. So the one with higher percentage one is called the major product, the one with lower one is called minor product. So how do we identify the major product and the minor product when the alkene is asymmetrical? We have to follow a rule called Markovnikov's rule. Right? Markovnikov's rule can help us to predict which is the major product and which is the minor product. The major product will be the one where the hydrogen is bonded to the carbon with higher number of hydrogen initially. Okay, one more time. Markovnikov's rule says that the major product is the one with hydrogen atoms added to the carbon atoms with more hydrogen atoms initially. So let's go back to the example. So if I have propene and asymmetrical alkene reacts with HBr, I get two different products. The first one, hydrogen is added to the carbon on the left. Second one, hydrogen is added to carbon on the right. Now, if you look at the carbon on the left and on the right, so let me just label L and R, yeah? Left and right. Now, carbon on the left initially has only one hydrogen. But carbon on the right initially has two hydrogen. So the hydrogen at the end, if added to the carbon on the right-hand side, that product, which is this one, will be the major product. The first product, hydrogen was added to carbon on the left. Initially only one hydrogen, less hydrogen. So that is the minor product. So why does this happen? So what's the concept, what's the ultimate reason behind this Markovnikov's rule? It is because of the carbocation that is formed in the mechanism. Okay. Now, carbocations, different types of carbocations, they have different stability. Okay. The carbocation that is bonded to more alkyl groups, okay, more R groups. R is alkyl groups. So what are alkyl groups? Methyl group, ethyl group, propyl groups, any of these, they are all alkyl groups, right? So the more alkyl groups the positive carbon is bonded to in the carbocation, the more stable it is. So this positive carbon is bonded to 3 alkyl groups. Then this one bonded to 2 alkyl groups. This one bonded to 1 alkyl group. This one no alkyl group. So the most stable one is this, the one bonded to 3 alkyl groups, followed by the one bonded to 2, followed by the one bonded to 1. So the one without any alkyl group is the least stable. Positive carbon is bonded to 3 alkyl groups. We call it tertiary carbocation. Yeah, this is read as tertiary. If bonded to two alkyl groups, this is a secondary carbocation. Bonded to one alkyl group, we call it primary carbocation. So tertiary carbocation is the most stable one, followed by secondary carbocation, followed by primary carbocation without any alkyl group. This is the least stable carbocation. Right now, let's go back to this example, propene with HBr. I'm going to write both the mechanisms for the two different products. So the first mechanism First mechanism, I want to show that the hydrogen is bonded to the left-hand side carbon. If hydrogen is bonded to the left-hand side carbon, that will leave right-hand side carbon to have a positive charge in the intermediate. So at the end, the right-hand side carbon will combine with the bromide ion and form a halogenal alkane, 1-bromopropane. Now let's look at the intermediate. This intermediate, the positive carbon is bonded to only one alkyl group. So this intermediate is a primary carbocation. Now let's write the mechanism for the formation of the second product, 2-bromopropane. Now this time I'll make the hydrogen to be bonded to the carbon on the right. Leave carbon on the left to have a positive charge in the intermediate. Then the bromide ion will donate its lone pair to the positive carbon. We get our second product, 2-bromopropane. Now let's look at the intermediate. The positive carbon is bonded to one alkyl group, two alkyl groups. So for the second mechanism, a secondary carbocation is formed. So just now we looked at the stability of different carbocation. Tertiary is the most stable. Secondary followed by secondary, and the least stable one is the primary carbocation. So if we compare these two carbocation, secondary carbocation is more stable. So the second mechanism produces a more stable intermediate. Now you know all reactions will occur because they go to a more stable direction. So if secondary carbocation is the most stable one, then more of this secondary carbocation ion will be produced in the reaction. That will proceed to more 2-bromopropane as product. That is why 2-bromopropane is the major product. So if you have asymmetrical alkene, draw the two mechanisms, compare the two carbocation ions, see which one is more stable. That will be your major intermediate, therefore proceed to major product. So all reactions will want to produce more stable intermediate, more stable product. Right? So if that intermediate is more stable, that will be produce more. So from that more stable intermediate, right, we proceed to more products from that intermediate. That is why 2-bromopropane is the one with higher percentage in the mixture of these two products. Right? So Markovnikov's rule says that the major product is the one with hydrogen added to the carbon with more hydrogen atoms initially. So before you look at the product, you look at the molecule first. Start counting the two carbons sharing the double bond, left and right. Which one initially contains more hydrogen atoms? Now it must be hydrogen atoms that are directly bonded to the carbon only. Right? Please do not include this carbon in the CH3. We only look at the hydrogen atoms that are directly bonded to the two carbon in the double bond. Right? So this carbon directly bonded to only one H, this carbon directly bonded to 2H. So if the hydrogen is added to the carbon with 2 hydrogen initially, that will be our major product. But this Markovnikov's rule can only be used to predict the major and the minor product. Please do not use this as explanation. Your explanation for why one of them is the major product, it is because of the stability of the carbocation ion. Explain in terms of which carbocation ion is more stable. Okay, now let's look at why. So why bonded to more alkyl groups means more stable? Now all this carbon has positive charges, right? So positive carbon, positive carbon, positive carbon, that's why they are called carbocation ion. So if they are bonded to more alkyl groups, these alkyl groups are electron donating groups. Yeah, that means they like to push their electrons to their neighbor. So all these alkyl groups are pushing electrons to this positive carbon, making the positive charge on the carbon is reduced because they are neutralized by the electrons donated by these alkyl groups. So if they are less positive, they are more stable. Stable means they like to stay as they are, they don't like to change, right? So they are stable. So more alkyl groups, less positive is a carbon, then more stable is the carbocation ion. So tertiary has 3 alkyl groups. So this carbon is the least positive. Primary carbocation ion has only 1 alkyl group. So this carbon is the most positive one, so it is the least stable. So this electron donating effect of alkyl groups is also called the positive inductive effect. So alkyl groups, they have positive inductive effect on their neighbor, on the adjacent atom. So more alkyl groups, more stable. Now I have practice 9 for you to write 2 different products for the reaction between this cyclic alkene and also HCl. So try to draw the 2 products and identify which one is the major product.